Hello, discrete math fans. We're going to talk about composition of functions. We want to combine functions, and the way we'll combine functions here is we're going to take the output of one function and put that into another function as an input. For example, if you take the function h of x equals sine of x cubed, we can think of this as being two functions that are composed. We start with some number x, plug that into the function g of x, and we get an output, some new number. We take that output of g of x and plug that into f of w equals sine w. And that's how we get f of g of x equals sine of x cubed. Now you actually have plenty of experience with composition functions. You studied this in calculus. In particular, you've studied the chain rule for how to compute the derivatives of composite functions. All right, so here's the definition of a composite function. We let f be a function that maps from x to y prime, and g is a function that maps y to z. It needs to have the property that the range of f is a subset of the domain of g. And then we define a new function, g circle f. That's going to map from x to z. So that's how we're going to describe this thing. This is g circle f. And g circle f is just g of f of x. So we take the output of f and plug that into g. So g circle f, that's called the composition of f and g. Here's a picture to describe what's going on with g circle f. We start with an element in the domain of f, and this gets mapped over here to f of x. So the codomain of f needs to be a subset of y, or really just the range of f. That way we know that whatever we're plugging in to g, this f of x, is going to be in the domain of g. And so our output then is g circle f. So this describes it as a two-stage process where we plug something into f and the output of that gets plugged into g. And now we're going to think of this really as a one-stage process. Okay, that's all for now.